Okay, A4 and A5 are review sessions. So A4 talks about factoring. I'm not going to spend a whole long time on that. Factoring, there are two steps of factoring. Step number one, you look for the greatest common factor. And step number two, you count the number of terms. It's either you have two terms, it has to fit one of those three. Three terms, that takes about an hour to explain, and four terms, you use grouping. So I just want to jump straight and do a few problems. Directions. Use quadratic formula to find all the zeros. If you recall, given ax squared plus bx plus c equals 0, x equal negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So if I come across a problem that doesn't factor, and this is on page 824, I would really use a quadratic formula. If I want to know where this equals 0, I'll say, well, x equal negative b, that is minus a negative 2, plus or minus the square root of b squared, negative 2 squared, minus 4, a is 8, and c is a negative 1, all over 2 times a. And that will always work. Let me just make that look nicer. So x will equal a 2 plus or minus the square root of 4. Negative 4 times, so 3 negatives, 2 negatives will give a positive. 4 times 8 is 32. And that would mean x will equal 2 plus or minus square root of 36 over 16. That would be 2 plus or minus 6 over 16. 2 plus 6 is 8 over 16, which is 1/2. And 2 minus 6 is a negative 4 over 16, which is negative 1/4. Now, I have one of each. Factor each polynomial completely. Well, let's see, these are 3 terms. I use this trick. You could use any trick that you learned. Add to get 12. 6 plus 6 is 12. Again, there are 4 ways of doing this problem. So 3, and to get negative 12, they're both negative. Since the first has a variable, split that in the first, the last. So that is 3x minus 2 squared. Done deal. If I look at so this is this case. How did you learn it? You apply it. But here, I see those and I think of, okay, can I write those as 2 squares? What do you square to get x to the 4th? X squared. What do you square to get 256? 16. So, according to this formula, you write them without the squares. So you write them without those squares twice. 1 time minus 1 time plus. But do you notice this is a perfect square again? That breaks into 2 pieces. X and a 4, x and a 4, 1 time minus 1 time plus. Do not forget to copy the x squared plus 16. And the reason I'm not doing anything to this, I only have a minus for a square. I don't have a plus. I'm going to shift this a bit to the right. And when I look at this problem, I notice there are 2 terms, so it has to fit those. But I notice it matches the cubes with a plus. So what do you raise to the 3rd power? And what do you raise to the 3rd power? You raise z to the 3rd power, you get z to the 3rd. You raise 5 to the 3rd power, you get 125. So you write it without those cubes right there. Without the cubes, c plus 5. You square the first. You square the last. And you multiply those. The last is always positive, and this is always the opposite of that. So again, I'm not teaching you how to factor, I'm reviewing. And that's why we're not going over the full details of those. And if you see 4 terms, you would be thinking of grouping. That is, make sure they're in descending order. Take the first 2. What's the greatest common factor between those? 4x squared. 4x cubed divided by 4x squared is x. 8x squared divided Positive over positive is a positive. 8x squared divided by 4 is a 2. You always take that sign. Negative x divided by negative 1 is x, and negative 2 divided by negative 1 is x plus 2. Then you notice that this repeats every time. Factor that out. And you would be left with 4x minus x squared minus and a 1. And that's not the end of it. This is a perfect squared. What do you square to get 4x squared? 2x. What do you square to get a 1? A 1, you write it twice. That's matching this. 1 time negative, 1 time positive. So this is a quick refresher on factoring. I'm going to shift this up just a bit to make this. There we go. And now when they say find the zeros, well, what does that mean? That means set this equal to 0. Well, we factor. Take x out, you would have 2x minus 3 left. So either x equals 0 or 2x minus 3 equals 0. Again, when I teach this, I spent a long time on this, but here we are just reminding you of how this works. And it says find all the zeros, set this equal to 0. Remember, if you have a square, you could use the squared property. Move the 36 over. And square root both sides. And don't forget, whenever you square root both sides, you always pick up plus or minus. Square root of 36 is 6. So x equal negative 1 plus or minus 6. Or x equal negative 1 plus 6 is a 5. Negative 1 minus 6 is a negative 7. And that takes care of this set of problems. And the last thing I want to tackle, in algebra, you do tackle the square root of 4 minus x. Now we're dealing with quadratic. Luckily, we know a bit about graphing now that we did before. So let's see how this works. And even index radical, anytime I want to deal with domain, I take the quantity underneath the radical, called the radicand, and I set that to be bigger than 0. Now the easiest way out, bigger than or equal to 0, the easiest way out is a graph. A rough sketch. Isn't this an upside down parabola shifted up 4 units? It crosses at negative 2 and 2. And if you say, I want to know where is this bigger than 0, where's this graph bigger than 0? Isn't it right there? So wouldn't you say the answer would be y is bigger than 0 for what are those values? Wouldn't you say for x being between negative 2 and 2? The reason I'm including those because it's included. So that might be something new. We're going to barely touch on that, and that's that. And the homework is a bit awkward this time. Let's see if you could make sense out of it. You're going to do page 824, number 1, 5, and 55. Numbers 9 through 53, I'm giving you 3 options. Either you do the odds, or you do every other odd. Every other odd. Or every other odd. Skip 3 and 5 do 7. Skip 9 and 11 to 13. Skip 15 and 17 to 19. So, it's up to you. You could do this if you don't need that much on factoring. Again, it's as need basis, but I assume that you know how to factor from this point on, and we will factor later on. So, this is all for this section. Now we're going to tackle the other section today.